So for decades, using software was, a lot like operating a deterministic machine on a factory assembly line.
Right.
Like you pull a specific lever, a gear turns, and a piece of metal gets stamped.
Yeah.
You have to do the actual work. The software is just completely inert without your exact step-by-step commands.
Yeah, entirely reactive.
Exactly. But right now, we are watching that assembly line wake up. We're doing a deep dive today into a massive stack of technical research and industry trends curated from the desk of Andrew Kagan.
Which is always a goldmine for this kind of stuff.
Oh, absolutely. And a, frankly, terrifyingly clear picture is emerging from this week's notes. We are moving from AI that just talks to you to AI that actually acts entirely on its own.
It's honestly the most significant architectural shift in enterprise tech since the move to the cloud. I mean, what Kagan's newsletter tracks this week across Azure, Microsoft 365, DevOps, security, it all points to one undeniable reality. We are officially entering the era of the agentic enterprise.
The agentic enterprise. Our mission today is to pull apart this massive stack of updates for you. So we're going to look at the new data pipelines, the Azure infrastructure, the end-user Microsoft tools, and the very sobering security realities of handing over the keys to autonomous digital workers.
Yeah, because it's not just a software update, it's a totally new paradigm.
Right. And to really grasp the mechanics of what's happening, you have to understand the fundamental shift from stage 1 AI to stage 2 AI. Like stage 1 was chat, stage 2 is agents.
And that distinction isn't just marketing speak, it's completely different. Chat is fundamentally question to answer. You ask a language model to draft an email, it gives you the text, but then you, the human operator, you still have to copy that text, open your email, paste it in, and hit send.
You are the bottleneck.
Exactly. You are the API between the AI and the real world. Agents, on the other hand, they operate on a goal-to-result framework.
So instead of asking for an email draft, you give the agent a goal, like resolve this customer's billing dispute. And to do that, it uses this observe, think, act loop, right? It observes the customer's email, thinks about the billing policy, acts by querying the Stripe database, observes the result, thinks about the refund amount, and then acts by sending the final email. It just loops autonomously until the goal is met.
Precisely. But, an agent can't just do that out of the box. Think about your own onboarding process when you hire a human employee.
It's a nightmare.
Right. If you bring in a brilliant new financial analyst, but you don't give them context on your company's accounting rules, and you don't give them credentials to access your ERP system, they are useless.
Right. They can't do anything.
Exactly. Agents require the exact same onboarding. They need persistent context, and they need tools.
Okay, let's talk about that context first, because the way developers are building systemic memory for these agents is fascinating to me. You'd think they'd be using some massive, complex, proprietary database system, but they're actually relying heavily on lean, specific markdown files.
Yeah, simple text files.
Right, like files with a .md or .mmd extension just sitting in a designated repository. Why rely on plain text markdown when we have, massive vector databases at our disposal?
Well, it really comes down to token efficiency and compute economics. Every single time that agent runs through its observe, think, act loop, it has to reread its core instruction.
So, wow. Every time?
Every single time. It has to re-ingest its system prompt, its brand voice, its operating procedures. If you use a heavy PDF with complex formatting, or, if you make a sluggish database for its core persona every 3 seconds, you are burning through your token limits.
And slowing the agent down to a crawl.
Exactly. Markdown is incredibly lightweight. The model can parse a claude.mmd or a memory.mmd file almost instantly, so it gives it a highly efficient deterministic grounding before it actually takes an action.
Okay, that makes total sense. Lean context equals fast execution. But context is only half the battle, right? The agent also needs tools to execute the work. And this is where we get to one of the most critical industry trends. Kagan highlights MCP, or the Model Context Protocol.
Oh, MCP is huge.
Yeah. If you are listening to this and you build or buy enterprise software, MCP is the acronym you need to care about right now.
Absolutely. To understand why MCP is such a breakthrough, you just have to look at the old way we integrated tools.
Yeah.
If you wanted an AI to talk to Slack, you had to write a custom API integration.
Right.
If you wanted it to talk to Gmail, that's another custom integration. Stripe, another one. You end up with this unmaintainable web of point-to-point connections.
The classic N-squared integration problem. This is an absolute nightmare to maintain.
Exactly. So MCP solves this by acting as a universal translator. It standardizes how AI models connect to data sources and tools. The AI only needs to know how to speak MCP. Right. And the sauce application only needs to expose an MCP server. Suddenly, the AI can natively interface with any third-party tool without all that custom hard coding.
That's incredible.
And this is fundamentally altering enterprise purchasing decisions. Like today, if a SaaS vendor doesn't offer an MCP endpoint, businesses are just refusing to buy the software.
Because it breaks their automated agentic workflows.
Yeah.
You can't have an autonomous factory if one of the machines refuses to speak the network language.
Precisely.
But, even with universal translators, we still have the hallucination problem. If an agent is making decisions autonomously, how do you ensure it's operating on actual facts and not just making things up?
Yeah, that's the big question.
Right. So the updates from Microsoft Foundry introduced this concept of the 4 IQs to ground these agents. You have Web IQ for real-time internet data, Work IQ for your personal Microsoft 365 graph, like your emails and chats. Then there's Fabric IQ for enterprise-wide data lakes, and Foundry IQ, which sort of sits on top to orchestrate it all. Why partition the intelligence like this, though? Why not just dump it all into one massive context window?
It's all about context poisoning. If you dump a user's personal calendar, the entire public internet, and a company's secure HR data lake into a single unstructured prompt, the model just loses its ability to weigh the reliability of the information.
Oh, I see.
Yeah, it might prioritize a random blog post over your CEO's internal memo. By architecturally separating the retrieval into these 4 IQs, Foundry IQ can conditionally route the agent's reasoning.
So if the agent needs to check inventory, it strictly queries Fabric IQ.
Exactly. It isolates the data streams to ensure accuracy and critically respect data governance boundaries.
Which brings up a really interesting debate about the models themselves. Microsoft Research just published details on Orchard, which is an open framework designed specifically for scalable agentic AI.
The Orchard paper is fascinating.
It really is. And what Orchard proves is that you don't actually need a massive trillion-parameter frontier model to do complex work. They demonstrated that a relatively small, open-weight model, or talking just 3 billion parameters, can actually rival the software engineering capabilities of massive models, as long as it's operating inside a highly structured agentic framework like Orchard.
And the implications for enterprise architecture there are just massive, because running a trillion parameter model is incredibly expensive.
Oh, totally.
Pushing millions of tokens through it for routine tasks will just bankrupt an IT budget.
It's like using a massive V12 engine just to drive down your driveway to check the mail. You don't need a Lamborghini for that.
No, you definitely don't.
If you take a highly efficient 3 billion parameter model, give it a sharp markdown context file, and hook it up to precise MCP tools, it's going to execute routine tasks faster and vastly cheaper than a raw, untuned supermodel.
Exactly. It forces IT leaders to adopt a multi-model strategy. And if we connect this to the end-user experience, this completely redefines how we interact with software. If the agent is doing the work in the background via MCPs and querying data via these localized IQs, the user doesn't really need to open the actual application anymore.
Right. This perfectly aligns with the ATY trend, agent-to-user interface. Traditional dashboards are just dying. The agent just dynamically generates a user interface, maybe a temporary React component, only when the human actually needs to approve something or view a chart.
The software essentially becomes entirely headless.
So how does this headless agentic capability actually show up in the tools you use every day? Let's look at the Microsoft 365 and Power Platform updates rolling out in July 2026. The sheer volume of model integration here is staggering. We are seeing the deployment of the new GPT-5.6 family, specifically the Sol, Terra, and Luna tiers, right alongside Claude Sonnet 5, directly inside M365 Copilot.
Yeah, and the way they are weaving it into the user experience is incredibly fluid now. Like in Copilot chat, you don't even have to switch contexts anymore. You can just @mention specific agents.
Oh, wow.
Yeah, you just type @Word or @Excel right in your chat flow, and that specific applications agent drops into the conversation, fully aware of your context.
And they are respecting the foundational data governance we just talked about, right? Copilot in Excel can now natively ground its analysis directly in governed Power BI data.
Yes, and let's explain the mechanism there, because it's a critical compliance feature. When Excel queries Power BI, it isn't just extracting a flat table, it queries the semantic model while strictly honoring row-level security, or RLS.
Okay, meaning what exactly?
This means the agent mathematically cannot hallucinate or retrieve financial numbers that the specific human user doesn't have the permissions to see. The data governance applies to the AI AI just as it applies to the human.
That is such a relief. Meanwhile, Copilot Studio is leveling up how admins build these workflows. They've introduced 3 distinct harnesses: a standard harness, a chat harness, and a brand new GitHub Copilot harness. That last one is explicitly designed for building autonomous business processes where the AI writes and executes code dynamically to solve problems.
It's huge. It allows an organization to automate highly complex multi-step logic that previously required, an entire dedicated engineering team to maintain.
Okay, I have to challenge the premise here for a second, though.
Oh, for it.
We just listed off GPT-5.6, Sol, Terra, and Luna, plus Claude Sonnet 5. And the Kagan notes also mentioned the open-weight Kimi K3 model, which boasts 2.8 trillion parameters and a 1 million token context window. As an enterprise user, how on earth am I supposed to know which one to pick?
It's a lot.
Aren't we just throwing a massive horde of stochastic parrots at users who just want to write a status report? And by stochastic parrot, I mean these models are essentially just massive statistical engines guessing the next most likely word in a sequence without actually understanding the meaning.
Yeah.
It feels incredibly overwhelming and potentially dangerous if they're actually executing code.
Well, it is overwhelming if you view it as a manual drop-down menu that a user has to navigate. But that's precisely why the architecture is moving toward automated model routing. The strategy isn't to force the user to pick its platform-level orchestration.
Okay.
When a prompt is submitted, the system evaluates the task against 3 vectors: intelligence, speed, and cost.
Ah, so it handles the triage for you.
Exactly. If you asked the system to perform a complex, multi-step strategic analysis of your supply chain, the router silently hands that off to a massive reasoning model, absorbing the higher token cost and slower latency because the task demands high intelligence.
Right.
But if you just ask it to draft a standard status update, it routes that to a lightweight model like GPT-5.6 Sol, which completes the task instantly at a fraction of the cost. The user never sees the complexity, they just get the result.
That makes the cost structure way more manageable. But if we pull back and look at the macro picture here, if we have agents dynamically generating UIs, pulling data, writing code, and executing business logic autonomously, it creates a massive pipeline problem.
Oh, absolutely.
Human developers and IT teams cannot physically review or deploy changes at the speed these agents operate. It forces a complete restructuring of the underlying developer infrastructure. You cannot run this autonomous factory on legacy plumbing.
Which perfectly explains the urgency behind the Azure and DevOps updates Kagan highlighted. Let's look at the Azure DevOps Remote MCP server, which is now generally available. This directly addresses the bottleneck you just mentioned.
Because previously, if you wanted an AI assistant like GitHub Copilot to analyze your DevOps pipeline, you had to clone the repository, host the endpoint locally, and expose your environment.
Right. It was tedious. But with the remote MCP server, the AI connects directly and securely to the hosted DevOps endpoint. The agent can pull work items, review pull requests, and analyze branch policies continuously without ever relying on local human environments.
It's so clean.
And that feeds directly into the rise of unit test agents.
I found the unit test agents fascinating in the notes, because as much as we love AI code generation, let's be honest, sometimes it outputs absolute slop.
Yeah, it definitely can.
It hallucinates dependencies or writes inefficient loops. A unit test agent acts as an automated QA loop. It sits in the pipeline, taking the generated code and relentlessly testing and refining it over and over until it validates perfectly. It transforms AI slop into trusted code before a human engineer even gets pinged for a code review.
It completely removes the human QA bottleneck. And we are also seeing deep structural upgrades to support these persistent agents elsewhere. Logic apps, for instance, are migrating to an out-of-proc hosting model to support .NET 10.
Let's unpack out-of-proc for a second. Why does out-of-process hosting matter for an AI agent?
Good question. Because out-of-process means the workflow executes independently from the underlying host runtime. Think of it as decoupling the worker from the factory floor.
Okay.
If the host environment needs a runtime update, or if it briefly crashes, your autonomous agent operating in the Logic app doesn't just die in the middle of executing a critical financial transaction.
Well, that's crucial.
It drastically improves the resiliency of background automation. They're also integrating managed identities natively into the standard extension, which eliminates the need to manage hard-coded credentials when these workflows authenticate to other Azure services.
Right. And as these AI platform deployments scale up, networking becomes a nightmare, doesn't it? Managing the BGP routes and cross-cloud connectivity manually is just impossible. So Azure has made their virtual network routing appliance, generally available, which basically abstracts away all that multi-cloud routing spaghetti. But the infrastructure update that really caught my eye is on the hardware and server side. Azure Local now has confidential virtual machines in public preview, and they are bringing in Intel TDX support.
Wait, what does hardware-rooted attestation actually mean in practice for an AI workload?
It means we are moving security down to the silicon level.
Really?
Yeah, Intel TDX, or Trust Domain Extensions, provides hardware-level memory encryption for the virtual machine. In practice, this means that even if a highly privileged administrator goes rogue, or if the underlying hypervisor is somehow compromised, they mathematically cannot read the memory states of your AI agent.
Wow.
The workloads are isolated and encrypted at the hardware level, which is critical when you have agents processing highly sensitive proprietary data at the edge.
That is heavy-duty isolation. But if we want to talk about operational game changers, Windows Server 2025 introducing ARC-enabled hot patching is just wild.
Oh, it's a huge deal. Normally, updating a server's core kernel is like replacing the foundation of a house. You have to shut the whole operation down, kick everyone out, and reboot the system. It guarantees downtime.
And in an agentic enterprise, downtime means your digital workforce just stops. ARC-enabled hot patching completely changes that paradigm.
It's like using nanotechnology to reinforce the concrete foundation of the house while the family is still sitting at the dining room table eating dinner. It patches the memory dynamically without a reboot.
For site reliability engineers, or SREs, it is a monumental shift. You can deploy critical kernel-level security patches in memory across your fleet while maintaining strict compliance, and your AI agents never experience a dropped connection.
But, having zero downtime and lightning-fast deployment pipelines is fantastic for productivity until you realize it's equally fast for adversaries.
Yeah, that's the dark side of this.
The shift to constant connectivity and agentic AI radically expands the enterprise attack surface. And Kagan's notes on the security and privacy front are extremely sobering.
Very. Let's start with the newly disclosed vulnerability in Microsoft Copilot for Word. Security researchers demonstrated a sophisticated prompt injection attack. They placed hidden text inside a document white text on a white background that a human user would never see.
Wait, hidden text, just like the old SEO tricks.
Exactly like that. And when the user asked Copilot to summarize the document, that hidden instruction forced the AI to maliciously alter financial figures in the output. And then it embedded the malicious prompt into the finished file to infect whoever opened it next.
Which proves a terrifying point. System prompts are not a security boundary. You cannot just program an agent with a rule that says don't be evil or ignore hidden instructions. The AI is essentially a statistical engine. It can be manipulated if the data it reads contains overriding logic.
Precisely. Microsoft's response correctly emphasizes that the industry must move to deterministic memory isolation. You have to architecturally separate the AI's core operating instructions from the untrusted data it is processing. If the agent parses a Word document, that document's text must be treated strictly as passive data, restricted from ever interacting with the agent's executable memory stack.
And if prompt injection wasn't bad enough, we also have to talk about zero-click threats. The sources detail a major report on an Exchange cross-site scripting vulnerability, CVE 2026-42897. Now, impartially speaking, regardless of the nation-state origins, the report links it to the Laundry Bear group. The truly alarming part is the pure mechanics of the exploit.
It is entirely concealed.
Right. There are no suspicious URLs. There are no attachments to download. It triggers simply by the user opening the email.
Think about the implications of that. You open your inbox, you click on an email to read it, and the script executes.
That completely bypasses 2 decades of user security awareness training. We have spent untold millions of dollars and countless learning and certification hours teaching employees to hover over links and spot phishing domains. And now none of that matters. You just read the email and you're compromised.
It really invalidates the idea of the human as the primary security perimeter. In an era where automated agents can draft hyper-personalized, context-aware phishing emails and deliver zero-click exploits, you cannot rely on human awareness.
No, you can't.
The defense has to be structural. It requires absolute transparency into your software supply chain, which is exactly why CISA just released their heavily updated SBOM baseline.
An SBOM, a software bill of materials. It's essentially an ingredient list for your software.
Exactly. CISA updated the old 2021 standards because organizations must have machine-readable transparency. If a zero-day vulnerability is discovered in an obscure open-source component, you can't spend 3 weeks manually auditing your codebase.
You'd be breached 10 times over.
Right. Your security agents need to instantly scan your SBOMs to determine if that component is running anywhere in your environment and automatically isolate it.
You can't protect what you don't mathematically know you have. And furthermore, you need systems that react at machine speed when a breach does occur. The sources offer a very cautionary tale regarding CISA themselves. Their AWS GovCloud credentials were inadvertently left exposed in a public GitHub repository.
Which is a bad day at the office.
Yeah, mistakes happen, but the critical failure wasn't just the leak itself. It was that the keys remained valid for a full 48 hours after the exposure was known.
And in a legacy enterprise, maybe a 48-hour revocation window was, an acceptable risk. But in an agentic enterprise, automated threat actors will find those keys, authenticate, spin up rogue infrastructure, exfiltrate data, and cover their tracks in less than 48 seconds.
48 seconds? Wow.
Security architectures must now enforce zero-trust policies with instant automated token revocation the millisecond an anomaly is detected.
It really paints a stark picture of the challenges ahead. So let's pull all of this together. Looking across Andrew Kagan's desk, we've essentially mapped the nervous system of the new enterprise. We are moving away from software that waits for human clicks to an architecture where agents execute observe, think, act loops.
Yep. We're deploying models dynamically based on intelligence and cost, connecting them to our platforms via universal MCP translators, and grounding them with highly partitioned data architectures like the 4IQs to prevent hallucinations.
We are running all of this on upgraded Azure infrastructure, using unit test agents in DevOps and Arc-enabled hot patching to eliminate downtime. But to survive the transition, we have to implement hardware-level memory encryption, machine-readable SBOMs, and instant token revocation to defend against zero-click exploits.
It's a complete re-engineering of the enterprise stack. But if we follow this trajectory to its logical conclusion, it leaves us with a critical new problem to solve.
And what's that?
Well, we have agents natively generating their own headless interfaces. We have tools connecting machine to machine via MCPs. The software is talking to the software, generating the code, testing it, and executing the business logic autonomously. So are we now designing our enterprise networks primarily for our human employees or for our AI agents?
Which forces a very uncomfortable question. If an autonomous agent hallucinates or misinterprets its markdown context and autonomously negotiates a terrible financial contract with a vendor via an MCP connection, who holds the legal liability?
Exactly.
If the human is no longer in the loop, does the financial blame fall on the software vendor who built the model, the prompt engineer who wrote the systemic memory, or the CEO who deployed it?
That is the multi-million-dollar legal question that every enterprise architect and general counsel needs to be actively debating today before they turn the agents on.
It really is. The factory assembly line has woken up. The machines are operating themselves, pulling their own levers, and rebuilding the factory walls at lightning speed. We just have to make sure they're building the factory we actually want and that we have the legal framework to survive it. Thanks for joining us on this deep dive. We'll see you next time.